Okay, let's go ahead and get started. The exam on Monday is going to cover Chapter A2 and Chapter 4.1. Basically, it'll cover everything off of the first two homework assignments. So today, as a way of reviewing, let's get started by seeing how many of you have questions about any of the homework problems. Good morning. You sign in, please. There we go. Who wants to go? All right, there you are. From the appendix chapter, A2. All right. 40, which ones now did you say? 43 and 45. Okay. Everybody there in the book? And the first thing it tells us is that the triangles in each pair are similar. Correct? What does that mean? What was the other choice? The angles are the same, and the lengths of the sides are different, but they're proportional. What was the other option? Not similar, but congruent. What does congruent mean? That it's the same triangle. They're both the same length sides, same angles. Now, let's take this. We're given the smaller triangle is a right triangle. $30 degrees, 60 degrees. We're given the hypotenuse is 4 and that the short side is 2. We're given a larger triangle that is similar. So what's the first thing we can do? We can immediately write in for C and B, for uppercase C and uppercase B, that this angle is 60 degrees and this angle is 30 degrees. And we know that the right angle, it's a right triangle, so we know that's a 90-degree angle. And we're told that the hypotenuse of this one is 8. All right? Now it wants us to find the length of the short side here, x, and the missing angles, A, B, and C. Well, we already know the angles are the same because they're similar triangles. So we put in 90, 60, and 30. And now all we need to do is find the length of this side. Because the triangles are similar, we know that the ratio of any two sides will be the same. So the ratio of 8 to 4 is going to be equal to the ratio of x to 2. And we solve for x. We multiply both sides of the equation by 2. And we end up with 16 divided by 4 is equal to x, or 4 is equal to x. Now that's the way you do it to show the work. The other example is 45. But this one's a little trickier because it's not a right triangle. Number 45, we're given a triangle with 95 degrees, 60, and 25. And we're given the lengths of these sides as 45 and 20. With this one unknown. Now on the larger triangle, we have angles A, B, and C. This is 30. This is an X, and this one is unknown. So again, because they're similar, we immediately know all three of the angles are the same. So A, B, and C are 60, 95, and 25 degrees. And now they want us to find the value of X. Well, we know the ratio of 30 to 20 is equal to 45 to X. Now, it would have been a whole lot more convenient if I had written those ratios the other way around. That would have just put X right on the top from the beginning. You can do that. That's a perfectly legitimate way to do it. I wanted to do it this way just to show you the extra step of formally solving it when X is in the denominator. And what we want to do first is put X in the numerator, so we simply multiply both sides by X. And we have 30x over 20 is equal to 45. And I'm quickly running out of room. So multiplying both sides of that equation by 20, we end up with 20 times 30 times x is equal to 45 times 20. The 20s cancel out here, and we're left with 30x equals 45 times 20. Divide both sides by 30, and we end up with x is equal to 45 times 20 divided by 30. And we can punch those numbers into a calculator. And we end up with, anybody else? 68.18. 45 times 20 is 900 divided by 30 equals 30. Has anyone spotted my error? Go ahead. Back it all the way out to where did I go wrong? Where did I make a mistake? How? Or rotate, they're wrong, that's right. Here I started off with 30 is to 20 as 45 is to x. Remember? Told you I put the x in the denominator? Well, I should have put these flip these around as well. Now, need to be careful. Don't make those are exactly the kinds of simple mistakes. Once you look back and you see what you did wrong, it's a head slapper. Oh, wow, how could I have made? But it's exactly the kind of mistake that anyone can make anytime. So be very careful about them. Now let's try this one more time. 30 is to 20 as x is to 45, and this time we're doing it in the right order. Multiply both sides times 45, and you end up with 45 times 30 divided by 20 is equal to x. That should also make another point for you to pay attention and take note of. By judiciously choosing the order I write the ratios in, so that I start off with x on top, this solution just became a whole lot simpler. One step as opposed to however many we went through. Punch these numbers into our calculator. And we get for x 67.5. Now, are there any questions about how this is done? Okay, then who has the next question? Okay, that's going to be back in chapter 4.
Yeah. For example, question 40, where they give you the 90-degree angle and then two sides, but they don't give you another interior angle.
Right.
How do you find those?
Aha. Okay, let's first set up the problem. We're looking at number 40 on page 267. All right, we've got 90 degrees, side A, side B, and side C is the hypotenuse. And then the angles are uppercase A and uppercase B. Now, on question 40, they give us A as equals 2, B equals 8. Now they tell us to find C and the hypotenuse and the two angles. So someone raise their hand and volunteer to answer it. Go out on a limb and answer this. How do we find C? Pythagorean theorem. Everybody say it with me. C squared is equal to 2 squared plus 8 squared. That's equal to 4 plus, somebody use a calculator to check my arithmetic. 8 squared is 64? 64. And y'all thought I wouldn't get it right. So we have C squared is 68. Is 68 a nice even square? It is not. It is not even close to a nice even square. It is, we're going to use a couple of decimal places, so we'll round it to 8.25. Oh, okay. Thought for a minute you were asking a question. I'm going to stop here, and I want to make this point because it does come up in other questions in your homework assignment. What would you do if they were saying we want the exact length of side C? Of 60, yeah, exactly. Write it as 68 under the radical, the square root of 68. That is an exact number. Not every solution has to be brought out to a decimal point answer or to an integer answer. Okay. So we found C. And I actually should not write it this way because what I should write is C is equal to the square root of 68, which is approximately equal to 8.25. 246 if you want to write it out to 3. Now, what else are we looking for? What else do we need to know? We need to know the angles B and A, or A and B. How do we find those? We could. How would you find them using the tangent?
The tangent of A is equal to 2 over 8.
Exactly. That's a good answer. What about B? That's right. Tangent of B is equal to 8 over 2. And you can reduce those fractions easily enough, so I would expect you to do so. Are there any other ways we could get to these? At this point, how would you then find the actual angle? Because it didn't ask you for the tangent of the angle, it asked you for the angle. Now, this is one of those times where you either have a lookup table in a book or you have a handy calculator. Because we're not going to do the arithmetic or the expansion series or whatever other algorithm we might employ to do the calculation to find these angles by finding the inverse tangent. But the way you find the angle, A, then is equal to the inverse tangent of 1/4. B is equal to the inverse tangent of 4. So making certain that your calculator is in degree modes. I type in the number, press second function or inverse function or whatever key you have to press on your calculator to get the inverse tangent function. To one decimal place, it would be 14. To 2, it would be 03. What about B? $76. or 75.96. You want to throw in a couple of decimal places. How would you check your work to make sure that you got these answers were correct?
No, out of the 90.
We know the sum of all three angles in any triangle must equal 180 degrees. We know this one's 90, so the other two must add to 90. Do they? They're pretty close. I think that the way I wrote it out in decimal notation would be what? 89.99? So to 1 degree, to rounding it to integer values, they would equal 90. And you've confirmed that you got the answer correctly. Sometimes when you're working a problem, confirming that you got the right answer can be kind of tedious. More often than not, you're going to find that it's just a dead simple way to very quickly reassure yourself that you did not make a silly mistake somewhere going back at the beginning. So if you could take that extra second or two to confirm, it can be well worth it. You'll be surprised how often you can catch yourself making a mistake when it doesn't confirm, and then you have to panic and start looking for where you made your mistake. Go ahead. 63 on the same set. Finding the bearing of an aircraft. Okay. A DC-9 aircraft leaves Midway Airport from runway 4 right, whose bearing is north 40 degrees east. After flying for 1/2 mile, the pilot requests permission to turn 90 degrees and head toward the southeast. The permission is granted. After the airplane goes 1 mile in this direction, what bearing should the control tower use to locate the aircraft? Okay, well, first thing we need to do is be happy that they put in a 90-degree angle. That makes it a right triangle, right? How many of you have ever taken flying lessons? Well, anybody? You have? Then you are probably the only two people in the class who are going to understand about runway 4. Yep. Yep. They do. They round heavily. Okay, so let's start with a compass heading. That's north. Now 40 degrees north is actually degrees from the north line, correct? So what does that tell us this angle is? 50 degrees. Now, if you worked this problem and you put the 40 degrees here, I'm not going to dock you points for not knowing how the airports and how aeronautical navigation reckons angles relative to the compass. But we're going to do it this way, so if you haven't done it yet, take notes. Now, how far does he travel in this direction? 1/2 mile. At which point he makes a 90-degree turn to the southeast and travels 1 mile. That's our hypotenuse. We need to find this angle. Well, that is what they asked for, right? The heading. So that's what they're asking for, is this angle. How might we find that angle? We could find the hypotenuse first, but let's think this all the way through before we start, because you can actually, if you think about how you're going to solve it first, there are usually, especially in trigonometry, there are usually options. You could look for sine, you could look for cosine, and as before with, simply just the simple choice of whether to put the, which way to set up the ratios when you're looking for. Okay, what would the tangent of theta be?
Or 1/2.
Would be, this is and yes, you're quite correct. This is exactly the point I was making. We could start by solving for the hypotenuse and then using the definition of the hypotenuse, the ratio of either side to the hypotenuse as the sine or the cosine of the angle. But if we just think a minute and set it up judiciously, we know that the tangent of this angle is the opposite divided by the adjacent. One divided by 1/2. Now, what can we immediately do to simplify that? No, 1 divided by anything is the reciprocal of that thing. Well, the reciprocal of a reciprocal is the thing you started with. In other words, 1 divided by 1/2 is just 2. Just think it through. How many times will 1/2 go into 1? 2 times. So the tangent of theta is equal to 2. The theta then is the inverse tangent of 2. You will find that with sine and cosine, there are certain angles where you get nice round integers. That doesn't happen with tangent. Who else has who has a number for me? Very good. Yeah. We got a whole nother half hour, folks. Y'all are getting free homework points. And for the record, any of you who've already turned in your homework, if you want it back so you can redo it, say the word. Yes.
The one question I had is how we wanted to write the answer for it. So if we have the square root of a number, you want us to put it in our calculator.
In this case, did they or did they not ask for the exact value? That's why I was pointing that out a while ago. If they say if they tell you to find the exact value, you don't round and you don't use the approximately equal to. Put in this case, the correct answer is the square root of 7. You can't, that's as exact as you can get. Who's next? Find the distance between two objects. Okay. We've got a blimp in the air. We got a football stadium over here and a football dome over here. I don't know, Cotton Bowl in the Astrodome. Do we have, oh no, that's a planetarium. Doesn't matter. What matters is that these two buildings, whatever they are 500 feet apart. No, they're not. You're right. Yeah, the blimp is 500 feet up. See, two right angles. Now, this angle is 32 degrees, and this angle is 23 degrees. Soldier Field? No, we aren't in Chicago. Guy who wrote the book must be from Illinois, I guess. I think we'll go back to the Cotton Bowl and the Superdome. How's that? Okay, so what are we looking for? We're looking for this distance right here. Well, we know this side is 500. And because we know this angle is 32, well, not necessarily. We know that this angle plus this angle must equal 90 degrees. Okay? And I don't guess, let's step through this one step at a time, how we get to this angle. And pay attention and you'll learn a shortcut in the process. This angle and this angle plus these two angles must equal 180. But these two angles are not equal. We can know these angles right off the bat without having to do any calculation. I'm just going to tell y'all how. When you have two parallel lines and they're bisected by a non-perpendicular line, opposite angles are always going to be equal. Okay? If this is 32, this is 32. If this is 23, this is 23. And knowing that, now we could find these two angles if we needed to. do we need to?
No, because we can use 23 and 32. You can use that to solve the Jason one. Because you know the office is 500.
We know that. But in order for 500 to be meaningful, we would need to know this line. Good morning. Gonna pass the sign-in sheet back. Take a seat. Yep. We could say that C times the sine of 32 is equal to 500. But in order to do that, we would have to know the length of C. In order to use tangent, we would need tangent of 32 is equal to 500 divided by A. And if we knew A, we would be done. Turns out this one might be a little bit more complex than some of the ones we've been working on. So we might have to do just a little bit more trigonometry to solve this one. What's the first thing we can do? We know this angle because we know that it and 32 is equal to, plus 32 equals 90. So 90 minus 32 is 58. And 90 minus 23, 67. I'm taking your word for that. Now we have some more information.
A is 58 over 32. Is opposite of A and then 32 is adjacent to it? Or is that not how that works?
Say that again. The
Tangent of A is 58.
A is not an angle. These are complementary angles. So we know, we can say immediately that C times the sine of 32 is equal to 500. We also know that C times the cosine of 58 will equal 500. What if we divide those two equations? Let's take a shot in the dark here and see what happens. We divide C times sine of 32 by C times cosine of 58 that's going to give us 500 over 500. That's not real meaningful. We might have ourselves a head scratcher here. We could write that. Tangent of 58 is equal to A over 500. We could write the tangent of 32 is equal to 500 over A.
Well, the first one would be a C, not A. Your C is your hypotenuse.
Yeah, the C is the hypotenuse.
There can you do 500 divided by the tangent of 32?
Say again?
Do 500 divided by the tangent of 32, and you'll get your distance.
You're on the right track. Look at the other one. Look at this one right here.
Then you do 500 times the tangent of 58.
Multiply both sides times 500. And you have 500 times the tangent of 58 degrees is equal to A. And that means the entire distance from here to here is 2 times A. So you would go 1,000, or 2 times 500, tan 58 is equal to the total distance.
I don't think that they're proportional.
Very good, you're right. They're not, because these angles are different. So, jumped a little ahead there, didn't I? But do you see that we are on the right track? What we have to do is find a whole nother distance, B. And how would we do that? Same way we did. 500 divided by B. I'm going to go over here to do it. 500 divided by B is the tangent, not of 58, but of 23 degrees. And I just transposed them back again, didn't I? We want B divided by 500 and that's equal to the tangent of 67. So B then is equal to, multiply both sides by 500, and we get 500 tan 67 is equal to B. Now then, from that, we can write our total distance equals A plus B is equal to 500 tan 58 plus 500 tangent 67 And we could actually simplify that by factoring out the 500. And now we have something we can punch into our calculator. Has anyone done that? Pretty close, isn't it? Now, have I gotten the point across that you need to be careful setting up your problems? These trigonometric functions, when you start dealing with ratios of opposites versus adjacents, especially when you start rotating your triangles around on the paper, you got to be very careful setting up your problem. And also be very careful not to assume just because of the scale that you happen to draw in that you got to be very careful not to make assumptions about things being symmetrical and equal when they're not. I think we got time for one more. Say again? 42 in this set. $42 is a bonus. Oh, you're back on the first homework? Ah, yeah, this is a good one to end on too. We want to find the area of the shaded portion, right? Well, okay, I'm just going to come over here. We have a square with a circle. I did. I put it on the outside. It sure did. The circle's on the outside. Yeah, 41 is the circle on the inside. Or 40, one of them. 40 has a circle on the inside. So, we start with a circle with a square in it. The square is 2 by 2. And we want to know the area of these 4 sections. Well, we immediately know the area of the square is 4 square units. But what's the area of the circle? To know the area of the circle, we need to know the radius. Once we know the radius, the area of the circle is pi r squared. That means we need to know this length. That's the diameter of the circle. So half of that length will give us the radius from which we can calculate the area of the circle. How long is that line? How do we find that? Pythagorean theorem. So we know that 2 squared plus 2 squared equals that length squared. So 4 plus 4 equals L squared. 8 equals L squared. Square root of 8 equals L. Now, are we looking for an exact value or just no? So we're going to then calculate the square root of 8 as 2 times the square root of 2. Let's just go ahead and do the calculator and get it. 2.828. And if we divide that by 2, 1.414. So R is approximately equal to 1.414, and therefore pi r squared which is about A is approximately equal to 8.89 square units. Well, if the area of the circle is 8.89, the area shaded is equal to the area of the circle minus the area of the square. That's approximately equal to 8.89 minus 4. 4.89. All right. Do we have any more questions? Any questions about the material we covered in these two chapters? Okay, well, homework is due on Monday when you come in, and we'll have the exam at that time. Tuesday. I have to be here Monday, but that's for a different class. Yeah. Tuesday. Y'all have a good day. Did you have more questions?